Hey guys, I want to start this lesson by looking at these graphs and just talking about what a tangent is to these graphs. So a tangent is a line that doesn't really cross through a particular point on a curve, but where it does touch that point on the curve, its slope is the same as the slope of the curve. So we could put a tangent line, say, right here, where its slope is going to be about the same. Okay, so it's not going to be perfect, but the slope is about the same. So right there, we've got a tangent. Now, as this tangent line follows along the curve, its slope changes with the slope of the curve. So there's another tangent right about here. Okay, and then as we get toward the top, this tangent line is now horizontal right here, and then it just continues to follow the slope of this curve. At the bottom, we're going to have another place where the tangent is horizontal. Okay, and then over here, we've got a tangent here, and as it follows the curve, it shifts its slope along with the slope of the curve. And then right here, we now have a horizontal tangent. Okay, then it shifts more with that slope. Up here, we'll have another horizontal tangent. Down here, we'll have another horizontal tangent. So these tangent lines will come up in the lesson that follows this. And then at the end, we're going to go over the end behavior and increasing and decreasing intervals.
Hey guys, today we're going to talk about critical points and extrema. So we'll start with critical points. A critical point is a point on a curve whose tangent is either horizontal or vertical. So I'll remind you about what a tangent is. If you think back to your geometry days, we have a circle, and a tangent is a line that touches that circle in exactly one point. This is similar to that. On a curve like example 1 here, a tangent can be found anywhere along this parabola. There's an infinite number of them, and they just kind of ride along the curve. So maybe you put one like right there, you put one right there, you put one there. But there's only one place on this graph where you're going to be able to put a tangent on there that is horizontal or vertical, and that would be right there. So there's a tangent that's horizontal. That makes this point right here, that point of tangency, a critical point. On number 2, you can put tangents all over this thing, but there's only one place where you can put a tangent that is horizontal or vertical, and that is right there. That makes this point of tangency a critical point. On number 3, if you just naturally follow this curve, you're never going to be able to put a horizontal or vertical tangent on it. You have a tangent right there or right there, something like that, but you'll never be able to naturally follow the curve and put a horizontal or a vertical tangent on it. So number 3, we would say, does not have any critical points. Concave, when we think of concavity, what we're actually referring to in this case is the inward side of the curve. In number 1, the inward side of the curve is here, and that's facing upward. So we would refer to this graph as being concave up. In number 2, the inward side is facing downward. So number 2 is concave down. And in number 3, that's more downward than it is upward. So that is concave down. In these next three graphs, you could draw a horizontal tangent right there. So I would say this right here is a critical point. In the second graph, there's a vertical tangent. So that's a critical point. In the third one, if you're naturally following along the curve, something about like that is the closest you're going to get to a horizontal or vertical tangent. So that third one, I would say, does not have a critical point. A point of inflection is a point on a curve where the graph changes what it changes is its concavity. So it changes from concave up to down, or from down to up. If you're reading it from left to right, right to left, doesn't really matter when we're talking about the fact that it's just changing its concavity. So in this first graph, the concave side on the left side of this critical point is downward, but on the right side of the critical point, it is concave upward. So this is a critical point, and it's also an inflection point. In the second graph, here on the left side of the critical point, its concavity is downward, but on the right side, its concavity is upward. So its concavity changes at this point, so it's a critical point, and it's an inflection point. The third graph did not have a critical point, but that point right there, on the left side of it, its concavity is downward. On the right side, its concavity is upward, so that point is an inflection point. Now we're going to shift to extrema. Extrema is just a plural for extremes. Extrema are maximum or minimum y values on a graph. And here are four types of extrema right here. The first one is an absolute maximum, and that is the largest y value. On the entire graph. So we'll say it's the largest y value over the domain of the graph. A relative maximum is also a largest y value, but it's not over the entire graph. It's just over a portion of the graph. So we'll say it's the largest y value over an interval of the domain. An absolute minimum will be the smallest y value over the entire graph. So the smallest y value over the domain of the graph. And a relative minimum is also a smallest y value. But it's not over the entire domain. It's just over an interval of the domain. So we're asked to locate extrema for the given graph. So we'll just go left to right. And this arrow points upward. So that means it's going to go up forever, which means this graph will actually not have an absolute maximum because it's going off toward infinity. It'll never reach it, so we can't locate the highest point on the graph. Right here, I would say that's our first extreme going left to right, and that's a low point, so it's a minimum, but over here, there's a lower point. So I can't call this one the lowest point on the entire graph. I would just say it's the lowest point on an interval of it. So that would be a relative minimum. And that is found at -4, -1. And as I trace along the graph left to right, I come to a high point, but it's not the highest point on the graph, so it's a relative maximum. It's the highest point in a certain interval of the domain. So a relative maximum is located at -2, 3. As I continue to trace left to right, I've got a low point, not the lowest, but a low point on a certain interval. So that's another relative minimum found at -1, 1. Continuing to trace left to right, I come to another spot. It's not the highest point on the entire graph because remember these arrows say that it goes up forever, but it is the highest point on that interval, so that's a relative maximum, and that is located at 1, 4. Continuing to trace, I come to the lowest spot that will ever be found on this graph. So that is the absolute minimum, and that is located at 3, -4. Now, if there was just one difference in this graph, this right here, curved and pointed down, that would make a couple changes. One, I would have a relative maximum right here. It's the highest point you can see on the graph, but I still have an arrow here that says it goes up farther. So that would be a relative maximum. That would also change the name here at what we called an absolute minimum. That would now be a relative minimum because this arrow says it's going to keep going down farther. You need to come back here and close those parentheses.
So now we're back to these graphs, and we are going to find the end behavior of this graph. So the end behavior we start with as x approaches -infinity. So that means as this graph goes left, what is the y value doing? The y value is going downward. It's going to keep going down forever. So the y value approaches -infinity. Okay, and over here, as the graph goes right, so as x approaches +infinity, the y value is going up forever, so y approaches +infinity. Okay, this graph, end behavior, on the left, so as x approaches -infinity, the y value is going up, so y approaches infinity. And as it goes right, so that means as x approaches +infinity, the y value is going up, so the y value is approaching +infinity. So on both ends, it's approaching, the y value is approaching +infinity. Now, increasing and decreasing intervals. So this graph starts off left to right by increasing until it gets right here. So this graph is increasing for all x's that are less than -2. Okay, so up until -2, it is increasing. At -2, it's not increasing or decreasing, so we don't want equal to, just less than. Then it begins to decrease. So from left to right, it is decreasing. And that is for x's that are greater than -2, but only until it gets here to 3, so less than 3. And then after 3, it begins to increase again. So it is increasing for x's that are greater than 3. This graph starts out by decreasing until it gets to -5. So it is decreasing for x's that are less than -5. Then it begins to increase. It is increasing for x's that are greater than -5. And then it stops increasing when x is -2, so less than -2. Then it begins to decrease again from -2 until it gets to 3. So it is decreasing for x's that are greater than -2 but less than 3. And then from x is 3 on to infinity, it is increasing. So its last interval is increasing for x's that are greater than 3.